So in this video, we're going to take a look at comparing two functions represented in different ways. From previous videos, they can be linear functions can be represented as tables, graphs, or equations. I think we'll do one or two examples here real quick. Right now, the y-intercept is the y that goes with an x value or input value of 0. So right now, this equation I know is going to have a minus 6.5 as the y-intercept. Down here, this equation has a y-intercept right there of -6. So and forgive me, drawing is quite challenging with this. Now, the other thing that might get asked is, what are the slopes? So the slopes, how much is the y changing for just one x? Or in this case, t and x are both, they're set up to be the input variable. So this is +1, while this one from -6.5 to -5.75. Well, if I struggle, I could pull up my calculator real quick. I like about positive 0.75 myself, but pull up my calculator real quick and type in, I'm going to expand this real quick, a negative got to get this that way we can use negatives on here. So 6.5 negative, and if I think it's 0.75, which I'm pretty sure it is, type it in. That gives me the next value. The other thing I could do is 5.75, again, negative, and subtract 6.5, negative 6.5. And the calculator gives me 0.75. So I know that this equation is 0.75 or 3/4 x. Meanwhile, the other equation, the movement that is happening, if we look really closely here, it's up 2, over 3 is not going to be quite spot on. If I go up 3 or right 4, that is exactly in line. So this equation is 3/4 x. So the two concepts that we're illustrating real quick in the example, 0.75 and 3/4, for those of you who don't believe me, Mr. Clee, I don't know how to handle 3/4. If I do 3 divided by 4 real quick on a calculator, it's 0.75. They're the same thing. You've had 3/4 once in your life. So right here, slopes are equal. The y-intercepts, the number when x is 0, the y when x is 0, right now, which one is greater? -6 on a number line, -6 is less below 0. It is greater than -6.5. And again, drawing with the Khan Academy tools is not the easiest thing, so it ends up a little bit sloppy. But so what has the greater y-intercept? Function 2. Hide myself and show you I know what I'm doing. I am. The rest of that is set up the same way. You're either identifying the y-intercepts and comparing them, or you're identifying the slopes and comparing them.